and get very enormous over time. So they're both similarities then and differences with Earth. But now I want to just show you some incredible features that these orbiters see. Today, very dry planet, dust and sand blowing around. These are sand dune deposits, and we're talking about several miles in extent here. And those in the front row can see little tiny ripples on top of these big dune deposits, and then you see other sized ripples here. We're actually seeing here wind-blown deposits that represent several different climate regimes that have happened in relatively recent Mars history. And so even something as simple as a sand dune is not simple when you look at all these textures that you see. And it's telling us a story about climate change in the relatively recent periods of Mars history. Here's another one, a very interesting, almost bird-like shaped dune here with a lot of little tiny dunes blowing around. And if you look even more closely, you can see even finer dunes here. Again, evidence of different types of climate regimes that speak a story that we're still trying to figure out about the recent climate history of Mars. But again, just beautiful images to look at. Here is a dust devil. It's just like in West Texas where you see these little mini tornadoes blowing along, and when they suck up the dust, of course, it comes out as a tail that the atmosphere blows around. And so again, evidence that this dust moving for activity, even in the form of these little dust devils, is very much an aspect of the modern Mars climate. Meteorite impacts. I talked about how that's such a prominent feature of the Martian crust. What people don't appreciate is just the incredible velocity when these meteorite impacts come in. The object that formed this crater is probably smaller than that little white dot in the middle, but look at the enormous blast that occurred, stretching out tens of miles, probably maybe 100 miles or so from the point of impact. This little tiny object creating this enormous explosion. And this is a very nice fresh crater on Mars, one of the ones that was found with the orbiters, and just illustrates some of the dynamics of a very important process for planetary surfaces. And then the pole of Mars, this is the ice accumulation on the North Pole, showing how the katabatic winds, as they descend from the polar plateau, get twisted around by forces due to the rotation of Mars to create these very nice curved features. So we do actually see evidence of water and CO2 frozen as deposits on the polar caps, and by interrogating the layers within these crusts, we learn again how the climate has changed over the last probably several hundreds of thousands of years and perhaps stretching to millions of years. So we do see the essential ingredient for life, water, preserved at the poles. But what is really fascinating is that when we look at the older terrain that has marked by all those craters, we see these huge river channels, and here you can see 50 kilometers, 30 miles, that float across the Mars surface, taking water from the southern highlands into the northern lowlands. Mars doesn't do this anymore. This is profound evidence of a climate early in the history of Mars that was much wetter and perhaps some degree warmer than it is today. This is why now early Mars and going to places where the record of early Mars is preserved is such a fascinating objective in these Mars missions. In fact, this is the southern highlands, the northern lowlands. Every little circle here is evidence of a crater lake, a crater that was filled with water at some time in the past. And you can see that the surface of Mars is just lousy with these things. They're just all over the place. And that's this feature here, a crater where a channel flowed in and filled it with water. The little squiggly blue lines, which might be a little hard to see from the back, every one of those represents a stream system where you had a very tightly dense integrated system of channels, which frankly this now collectively proves that it precipitated on Mars. So just beyond the fact that there's water somewhere in the crust of Mars, we've now been able to demonstrate with these modern observations at higher resolution that we actually had precipitation on early Mars. It's a huge step. Now, I can't tell you whether that was rain or whether it was snow. For sure, it was at least snow. But this is much more pervasive evidence of a wetter climate than we've ever been able to. And this database is less than 10 years old. This is like modern stuff. Okay, so there's this notion then that the early history of Mars, if you sort of look at time going across the block here, and this is the surface of Mars through time, that the early environment was much wetter with channels and volcanic activity and lakes and so forth than today. The climate's deteriorated substantially, we think perhaps some 3 to 4 billion years ago, to the cold, dry, forbidding climate that we see today. There might still be water at subsurface where the pressures are higher and the temperatures are warmer, but the really abundant water at the surface was way back in early time. So this becomes an objective. How can we look for rocks that were formed at that time that would tell us about the early climate of Mars and where we might look for evidence of life? So this shows where all the landers have been on the surface of Mars since the modern era of Mars exploration began. Viking 2 here, Viking 1 here. You tend to land in areas that are low enough on the surface so that you have enough atmosphere to allow you to slow down. It's one thing to land on Mars, it's one thing to land on Mars slowly enough that you don't destroy your spacecraft, and for that you need atmospheric cushion to help you slow down. So we can't really go into these red areas and brown areas. We're pretty much restricted to a trade-off between where we have enough atmospheric density at these lower altitudes, elevations, to land safely, but at the same time get into this older crust that contains this history of this fascinating earlier, wetter Mars. And so here is the very famous now Mars exploration rover. This would either be Spirit or Opportunity, which has a series of instruments on it that really mimic the field geologist, going out into the field with a good set of vision, binoculars, hand lens, and perhaps some crude instruments to analyze rocks, crack them open to see what they look like. And so really what this represents is a robotic model of a human field geologist going to Mars. Opportunity is the one of those two rovers that's still surviving today. It's a miracle story that nobody ever would have believed would be true, would have happened. It's been there for over 10 years. It's driven 25 miles or 35.5 kilometers, which has now just broken the Soviet Lunokhod record of about 30, actually it's now over 40 kilometers. The Lunokhod record was about 39. And so it's really made a major trek. Now one of the things it's done, we sent it to a place where we thought water must have been present at the surface based of minerals, but actually when we landed there, we made some interesting discoveries in that regard. We found rock deposits that looked like they were formed in a salt flat, that we had standing water, or at least flowing water that evaporated and formed salt deposits, and the kinds of deposits were not that different from the kind of salt flat we might see on the Earth. And this is exciting because on these environments on the Earth, in principle, life could live there. It might have to be adapted to high salt. We have organisms on Earth that could have lived in that type of environment. Unfortunately, that rover was not prepared to detect evidence of life, but it sure detected evidence of a very exciting environment. This is now just an amazing picture. This is probably less than 3 months old. We've now driven that 25 miles to the rim of a very large crater that now allows us to get to even older rocks. And for those of you in the front row, and maybe some of you further back, you can actually see the tracks of the rover over a mile away as it comes down along here, comes up, and the tracks are here, and then you can see it coming up this hill. And we're exploring these rocks here, trying to get deeper into the history of Mars when we think it was wetter and perhaps even more favorable for life. So right now, the rover is probably just about where I'm standing relative to this picture, and continuing to move to where we are looking for even more exciting rocks. So just an amazing image taken from 100 million miles away from the Earth. Okay, let's switch over to the other rover, Spirit. We landed that in a place called Gusev Crater, which is right between the highlands and the lowlands. And it's one of these places where we thought there was a lake. Here's the stream flowing into the crater, and then the water flowed out into the northern lowlands. But where we landed, everything we saw was lava rock. So we decided to drive to the Columbia Hills here because we saw some interesting features. And actually, the most interesting feature was this a pancake-shaped deposit called Home Plate, which was actually located down here in this valley in the Columbia Hills area. And these types of deposits are totally consistent with a hot spring, volcanic activity, water getting hot, interacting with that rock to make salt deposits like we see at Yellowstone Park, and also mineral deposits, which are very good for preserving fossil evidence of life. Again, we really weren't equipped to detect evidence of life, but we had detected evidence of an environment which one artist sort of recreates here as a sort of a Yellowstone-type hot spring geyser environment that was probably active about 3.5 to 4 billion years ago. So this is all artist's imagination, but it's basically the artist's rendition of what this particular environment might have looked like 3.5 to 4 billion years ago. This is very exciting because when you go to a place like Yellowstone and look at a big hot spring, it's an ideal place for sustaining microbial life. You've got a source of water, you've got chemicals coming out which can provide sources of energy for the life that's there. You have mineral deposits like the silica that's deposited around the margins that can preserve any organisms that are there as fossils. And there's a range of conditions here. So if there's a range of different organisms, you might actually be able to see a variety. The point is now, this is actually a different feature, but the point is now we have now detected evidence of that type of environment on Mars. Still haven't detected evidence of life, but by golly, we're getting awfully close to we are finding places now where if we had the right instrumentation and so forth, we might actually detect fossil evidence. We're getting that close. So this now is taking us to Gale Crater, where Curiosity rover is, another large crater right at the boundary between the highlands and the lowlands. And in this case, here's Gale Crater. It's a big guy. It's about 150 kilometers across. And we landed right here at the base of this central mound because that's a safe place to land. And the real interest for this landing site is this mountain itself, as I'll explain in a minute. Down the road there, you saw a model of the Curiosity rover. This is by far the most sophisticated spacecraft we ever sent to Mars. In terms of camera capability, in terms of instruments, it can do definitive identification of minerals, which tell you about environments, and identification of organic matter, if it's there, which tells you about conditions that were very favorable for preserving evidence for life that would really be important for our exploration. And so this is a much more capable rover being sent to a very exciting place right on the equator. Here we actually discovered mudstones so far in this mission that were clearly laid down in water. We see mineral deposits filling cracks within the mudstones. Here's the arm of the rover going down to obtain a sample to analyze it for the minerals. And we find evidence of indeed water, and it's not that salty. The acidity is very moderate. It's sort of what we call neutral pH water. And therefore, we published a series of papers saying that we have found an environment that could support life as we know it. The question is, we just don't know whether life was actually there. But this, compared to the environments I showed, well, compared to the opportunity environment I showed you before, this is a much nicer place. But it's perhaps another example of a nice place, just like the hot spring one that I showed you from the Spirit rover. So as you can see, we're not just finding water, we're finding places where water could be favorable for life. Here is the mountain view there that in Gale Crater that we're now driving towards. And this is a layer of record of history on early Mars. It probably spans hundreds of millions of years. So not only are we looking for an environment that might be habitable, we may be looking for a whole sequential history of environments that might have been habitable. So stay tuned. This is what we're going to be now doing over the next